So in part 1, we just found the trigonometric values for the special angles. I'm going to zoom in here so I can see this a little better. So we're just going to copy those values. So if you go to the next page where we did all the work, we're just going to neatly copy the values into this chart. So I'm going to do this. Why don't you do this? I'm going to pause the video. And actually I decided to show this. So if I'm going to write these down, when I'm writing my sine values down, let's say I'm doing this from memory, they're all over 2, and our rule is they count up. So I have 1, radical 2, radical 3. For the cosine values, they're also all over 2, and then I count down. So I have 3, 2, 1. The tangent values I pretty much memorized. As I said, we will have a way to do these. So they're radical 3 over 2, 1, and radical 3. And then for these values at the bottom, I really don't even memorize them. I'm going to pause the video to write in these. There's no real patterns. I know you don't ever really have to fill out a chart for them. You would just, and I'll do one just as an example. Like let's say I was looking for the secant of 45. I would take this value, radical 2 over 2. I'd flip it over. And rationalize the denominator. So this is going to give me 2 radical 2 over 2, and this is more work because I had flipped a previous version of it, like the 1 over radical 2 before. So this is just radical 2. Now my goal is not to have a messy chart. Sorry if you were copying me. So I'm going to erase that and just write in these values. So I'm going to pause the video and write in these values. So now that I have my chart filled in, basically if I look and I typed in any of these, so let's say I typed in on my calculator tangent of 30, that would on my calculator with more decimals give me 0.577 as we see in this chart. Remember this is in degree mode for the angle, and if I typed in radical 3 over 3, which is the value of tangent 30, that would also give me 0.577. Another common misconception, these radian values are just equal to the values above. So that's like if I told you, and I'm just going to estimate here, that I was 70 inches tall, and then I also told you that I was about, I don't know, not great at converting these things, but 185 centimeters or something like that. They're just two different ways to measure the same thing. The actual trig values are in the table here for the sine, cosine, tangent, cosecant, secant, cotangent. So I'm going to move to the last page now since we already did the second page. So here's our hints for memorization. Some of this didn't copy great, so these radian measures are pi over 6, pi over 4, pi over 3. So we're going to look at the table on the first page of the lesson. What pattern do you notice about the sine values? We've already really talked about this. So try to fill in this chart actually on your own from memory, and then we'll start to go over the patterns again. So I filled in my chart. I'm going to say these answers, but if you need to go back, you can go back to the previous page where we wrote down the patterns. So remember the sine values all over 2, counting up. The cosine values are all over 2, counting down. And lastly, the tangent we're going to go over in part D. So we wrote down the sine and cosine values, and now we're going to talk about how tangent can be found. So if it says, if you can memorize the sine and cosine values of the special angles, you can use a couple of relationships to find the rest. So this is called the tangent quotient identity. The sine value of an angle divided by the cosine value of an angle is equal to the tangent value of the angle. So I'm going to rewrite this just because it's a little sloppy here. So sine of A, sine of an angle, divided by the cosine of the same angle equals the tangent of the angle. So to show why this is true, if we substitute sine of A and cosine of A, which with their ratios, their actual ratios, sine of A would be the opposite over the hypotenuse, and cosine of A would be adjacent over hypotenuse. So I see this fraction, I know I need to keep change flip. So I keep the opposite over hypotenuse the same. I'm going to flip the hypotenuse over adjacent. So now if I multiply across, I'm just going to directly multiply across, not cancel. I get opposite over hypotenuse times hypotenuse over adjacent, or times adjacent. Sorry, opposite times hypotenuse over hypotenuse times adjacent. So here I'm going to cancel the hypotenuse, and I get opposite over adjacent, which is equal to tangent of A, okay? Probably better if I use a different variable other than A. This is not the A in adjacent, it's just an angle A. So I'm actually going to show you how this can be used to find the tangent values. Since I already wrote in the tangent values, I'm going to do this up at the top of the page. So for example, for 30 degrees, if I take the sine value of 1/2 and divide by the cosine value of radical 3 over 2, simplify that, I get 1/2 times 2 over radical 3. This time I am going to do the cancellation. Okay, that gives me 1 over radical 3. And if I rationalize the denominator, multiply both numerator and denominator by radical 3, I end up with radical 3 over 3, which is the value of tangent, radical 3 over 3. 45 is super easy to see because if I divide these two, I just get 1. And then even the 60 is pretty easy because these 2's would cancel. Right, so those 2's would cancel, and I just get radical 3 over 1, which is radical 3. So that's an option, or you can just memorize the tangent values. So at the bottom of the page, and as I said, yours looks fine. I'm going to write this in for people that might not have the packet. Just remember, if you don't have the packet, if at all possible, it's best to print it out. But so anywhere where you see this, there's basically just a pi. And it came through as a question mark on here. Okay, that looks good. So we're just going to write these values down. So I want you to pause the video and go ahead and write in your answer for each one as much as possible. Don't do it with a chart. I am going to go down the column first though. Okay, so cosine of 45, just going to talk through my thinking. That's in the middle, right, of my chart. So cosine goes 3, 2, 1. So it's going to be radical 2, and that's over 2. Pi over 4 is 45 here. So the tangent of 45, I know that's when like the opposite and adjacent are the same, so that's 1. Cosecant of 45, I'd probably find sine of 45 first. So I know sine of 45 is radical 2 over 2. So cosecant of 45, I'm going to have to flip that over, so I get 2 over radical 2. Multiply by radical 2 over radical 2. Giving me 2 radical 2 over 2, which cancels, and I just have radical 2. Secant of pi over 4, same basic idea. I'm going to work from cosine of 45. It would be very similar work to the work above because we know that we're going to have to start from a cosine value and then flip it over to find the sine value. The ultimate answer would be radical 2. For this one, just because sine and cosine have the same values at 45, so do cosecant and secant. So finish up this section and then we'll go over it. So now that you can see my answers, I would probably just pause the video and check your work. I'm going to do a quick explanation, but it might just be quicker to check it yourself. So now that you've checked your work, basically the top 4, okay, B, C, E, and F, I just use for memorization. If you don't, maybe you looked at the chart, trying to work to memorize as you do them. Notice for H through L, H, K, I, L, I did show all my work for them, and that's because in reality, if I was on a test, I don't really memorize those values, so I kind of have to work from the ones that I memorize. And just a note, if we were in class and at some point, just this part of the chart, let me move up the page, just this is something that we usually quiz on, so it's a really quick quiz and you're expected to memorize it. So just this chart is something that you'll want to know. So there is one more question at the bottom of the page. It says, where did you see the special angles earlier this unit? And you should remember right on our unit circle, and I kind of drew it before, that we saw that 30, 45, and 60 on the unit circle. So one thing to note, the end of your homework does have some kind of guided notes with the unit circle. I want you to try to figure them out on your own, but we will be going over those notes to start our next lesson. But the more you kind of do on your own, the better it's going to be once we get to that unit circle lesson.